So now in this video we're going to continue looking at the voltage divider. In the last video we looked at the resistor, the trim pot, and using a light dependent resistor to make voltage dividers. Now we're going to look at the voltage divider that's in the 555 timer. Of course you can't see it, but the way that the 555 timer works, you can tell that it has a voltage divider in it. So right now the trim pot is set all the way to the negative rail, and I will turn it to the positive rail, and we saw the output changed. So I had to get most of the way to the positive rail before it changed. Then I had to get most of the way to the negative rail before it changed. So we're going to take this apart and look at why. So now, one of the easiest ways to get a voltage divider is with a trim pot, and you just plug one of the inputs to the positive rail, one to the negative rail, and you get a fraction of the voltage depending on where the knob is turned. So this is a 10 kilo ohm trim pot. The value of trim pot does not matter as long as the load does not take any current to operate. So all this does here is look at the voltage at these two pins after we connect the trim pot. But the main thing is, once you get a good connection there, so the knob turned about halfway, about half the power supply voltage. I turn all the way to the positive rail. Now we have 5 volts at the output in relationship to ground. And then if I turn the knob all the way the other way, and don't lose my connection, there we go, then we get all the way down to 0 volts and anywhere in between. So now the 555 timer, it has a voltage divider in it, which is very similar to this. So you see we plug the power into the negative rail to pin 1 and the positive rail to pin 8 right there. So I have these resistors set like that, where negative is to the left there. So I make my connection to the resistor, and into that one we get about 1/3 of the power supply voltage of 5 volts. And then over here we get about 2/3 of the power supply voltage, and that is the two main voltages that the 555 timer looks at. So now the wiring of this circuit is really simple. As I said before, pin number 2 and pin number 6, they monitor voltages. So pin number 2 looks for when the voltage is 1/3 of the power supply voltage, and pin number 6 looks at when the voltage is 2/3 of the power supply voltage, and ultimately that changes the state of the load. So we're going to use a couple LEDs. I'm going to use the red LED for when the output is high, so it will go red to indicate the output is high. So I'm going to put the short pin, the cathode, to the negative rail here, and the long lead, the anode, up one spot, and that's the easiest way to make the resistor or the LED go directly to ground, is with that jumper there. And I'm going to use a 220 ohm resistor to protect it. Now we're going to the output of the 555 timer, which is low right now, and or high right now. And we know that by the direction that the LED is going. If it was turned the other way, it would block the voltage, and we would get nothing. So now we're going to use the blue LED to indicate when the output is low, and so it's going to come to this jumper. So we need the long lead, the anode, towards the positive side, short lead, the cathode. Again, we will just go one row off to the side, and we're going to take a 1 kilo ohm resistor because the blue LED is a whole lot brighter. So we'll put 1/4 of the current through it, and we'll see that now actually we can see the output was low, but the power is supplied, and I'm missing stuff. This is why you usually turn the power off while you're wiring, but there you go. So we have the resistor from pin 3 to the cathode, short lead of the LED, and then anode goes to the positive rail there. So right now both LEDs are on. That tells me that the 555 timer probably isn't outputting anything. We should have turned the power off. But in any case, let's plug in the trim pot here and come over here to where both of the pins are being monitored because of the jumper. Now you can see the blue LED is on. So it's clearly on. The red LED is off, and we will turn the trim pot, I think, towards the red rail. Nope, go down to negative rail. So right there, now the red LED is off. Now I'll turn the trim pot the other way. The trim pot started falling out of the board. This board kind of pushes these trim pots out. But there you can see now the blue LED is on. So depending on the position of the trim pot to a point, because there's hysteresis, it will determine whether the output is high or low. And let's see if I can do this without blocking the view. So right now the blue LED is on. We come here, and right about there the red LED comes on. Now we have to go back a bit before the blue LED comes on. So we have a range here where the LED has just flipped, but we go back the other way, it will stay on for a bit until we pass the other point. And so now we will use the multimeter to measure the voltage again in real time of the output of the trim pot. So you can see that it's turned all the way towards the positive rail, and we have a low output. I wired this so the blue LED will turn on when the output is low, so at the 0 volt reference point. And I have it wired so the LED, the red LED, will turn on when the output is high. But in any case, we have the full voltage. Once we get down to about 1/3 of the power supply voltage, then you will see that the red LED flips on, and then right about there the blue LED came on. So we have to get between or down to 1/3 voltage before the output will change states, and then we have to go all the way up to 2/3 of the power supply voltage before the output will change states, as you can see there. So there may be false triggering too. This isn't very steady, but in any case, the main takeaway is that there's a voltage divider in the 555 timer. So it's 3 resistive areas, and in fact, a lot of people say that the 555 stands for the value of the resistors: 5 kiloohms, 5 kiloohms, and 5 kiloohms. I don't know how true that is. I've seen other things that that say otherwise. But in any case, that may be a way you remember 555. Some people say that's the 3 resistors that make up the 1/3 and 2/3 power supply voltages that the integrated circuit monitors. So in any case, hopefully this video was helpful for you. Thanks for watching, and I will see you in the next video.